Have you ever stopped to think about how the most incredible things in the universe actually work? I'm talking about things like a bustling ant colony, or even the consciousness that's listening to me right now, inside your head. What if I told you they all come from the same, single, beautiful principle? It's like the universe has one great magic trick, and it uses it to create everything that matters.
Here's the puzzle at the heart of it all. You take a single ant. On its own, it's pretty simple, right? It follows basic urges, but you put thousands of them together, and you get an ant colony, a superorganism that acts with a stunning collective intelligence. How does that happen? How do you get intelligence from a bunch of parts that have none?
And this is where it gets really mind-bending, because that paradox, the one about the ants, it's the same principle that explains the genius of modern artificial intelligence and maybe the deepest mystery of all, our own consciousness.
All right, let's dive right in. We're going to start with our first case study, the incredible, complex world of an ant colony. And the key thing to remember here is there's no one in charge. No queen barking orders, no general planning the strategy. It just works. So how do you get this perfect division of labor with no manager? It's all about simple, local rules. Ants communicate using chemical trails called pheromones. So a soldier ant doesn't need a command. It just operates on a simple rule, something like, if I smell fewer than 10 forager ants today, my job is now forager. So what happens if another colony attacks and a bunch of foragers are lost? Well, the soldiers automatically switch roles to get more food. No memo, no meeting. The system adapts on its own. The intelligence isn't in the ant, it emerges from the network. So this amazing phenomenon, it's not a fluke. It has a name and a really fascinating history. Let's dig into the idea of emergence itself. It's a concept that stretches all the way from ancient Greek philosophy right up to Nobel Prize-winning physics. It all kind of starts with Aristotle, who just flat out said the whole is greater than the sum of its parts. But for centuries, the dominant idea was actually the opposite, something called reductionism, pushed by guys like Descartes. They thought you could understand anything just by breaking it down to its smallest bits. But the idea of emergence just wouldn't die. It kept, well, emerging, until it was properly defined and eventually became a cornerstone of modern physics.
Okay, so what's the difference? It's actually pretty simple. A resultant property is just addition. The weight of a pile of bricks, it's just the weight of each brick added together. No surprise there. But an emergent property is a brand new quality that the parts themselves just don't have. Think about it. A single atom of silicon has no color, but a brick made of them, it's red. A single molecule of H2O isn't wet, but a bunch of them together are. That new quality, that's emergence.
So scientists basically break emergence down into three flavors. First, there's weak local emergence. This is predictable stuff, like a snowflake. You get the conditions right and water molecules will always snap into that beautiful six-sided pattern. Then there's weak non-local emergence. Think of a flock of birds. You can't predict its exact path, but you know it happens because each bird follows simple rules, like stay close to my neighbors, but not too close. And then there's strong emergence. This is the really wild one, where the whole system actually reaches back and influences its own parts. Think about your thoughts, an emergent property, literally causing your physical neurons to fire. And the only major example anyone has ever proposed for that, you guessed it, human consciousness. Now let's look at how this concept completely revolutionized our world. We're talking about artificial intelligence and how it went from being a fancy calculator to something else entirely.
For decades, the Holy Grail, the Mount Everest for AI researchers, was the ancient game of Go. See, chess is incredibly complex, but it's mostly about short-term tactics and calculation. Go is different. It's about deep, long-term, almost intuitive strategy, and the sheer number of possibilities made it seem absolutely impossible for a traditional AI to crack.
I want you to just take a second and look at that number, 10 to the power of 172. It is a number so staggeringly huge, it's more than the number of atoms in the known universe. You could never, ever build a computer powerful enough to calculate every possibility. Brute force was a dead end. AI needed a new way to think.
And that new way of thinking arrived in 2016. In the middle of a high-stakes match against the world's greatest Go player, Lee Sedol, Google's AI, AlphaGo, made a move. Move 37. No human expert would have ever made it. The chance was less than 1 in 10,000. Everyone thought it was a mistake, a bug, but it wasn't. Dozens of moves later, it turned out to be a stroke of creative, alien genius that won the entire game. It was a true moment of emergent intelligence.
And that moment shows the difference perfectly. The AIs that beat chess, like Stockfish, are classical AIs. They're programmed with tons of rules and they just calculate millions of moves ahead. It's a ridiculously powerful calculator. But AlphaGo, a machine learning AI, wasn't programmed with strategies. It was just shown millions of games and told, learn. Like that ant colony, its genius emerged from the interactions of simple parts in a network. One is a calculator, the other is a thinker.
So, the triumph of emergent AI naturally leads us to the biggest mystery of them all, our own minds. Let's turn this powerful lens of emergence inward and look at that 3-pound universe sitting inside our skulls. This right here is what philosophers call the hard problem of consciousness. Your brain is made of billions of neurons. Not a single one of them is conscious. Not a single one of them feels joy or love or sees the color blue. So how does the simple firing of those mindless cells create the rich inner movie that you experience as your life? The brilliant physicist Sir Roger Penrose has a radical idea. Maybe the answer isn't in biology, but in quantum physics. Now to get this, we just need 2 quick quantum ideas. First up is superposition. It's this bizarre property where at the tiniest scales, a particle like an electron isn't in one state or another. It's in all possible states at the same time. It's only when we look at it that it picks one. It's weird, but it's real.
The second idea is entanglement. This is when 2 particles become linked in a way that's, well, spooky, as Einstein called it. If you measure one, you instantly know the state of the other, even if it's on the other side of the galaxy. It's a connection that seems to ignore space and time. Okay, so here's the theory from Penrose and his partner Stuart Hameroff. It's called Orch OR. They argue that tiny structures inside your neurons, called microtubules, act like little quantum computers. Particles inside them exist in superposition. Then, these quantum states get entangled across the entire brain. And when this massive quantum system reaches a certain point, it collapses all on its own. And, they propose, each one of those collapses is a single discrete moment, a single frame of conscious experience.
Now, you might be thinking, that sounds like science fiction. But here's the kicker. They did the math. They calculated how often these quantum collapses should happen in the brain. The answer they got? About 40 times per second. 40 hertz. And what's so incredible is that this number perfectly matches the frequency of gamma brainwaves, which neuroscientists have known for years are directly linked to conscious awareness.
So this theory, it does more than just challenge our ideas about biology. It starts a conversation with some of the oldest philosophical and spiritual questions humanity has ever asked about who we are, what happens when we die, and whether we have a soul.
Think about it. If your consciousness is literally a pattern of quantum information, what happens to that information when your brain stops working? Hameroff suggests it doesn't just vanish. It could just dissipate back into the fundamental fabric of the universe. It's a scientific idea that sounds an awful lot like a spiritual one. A soul, an essence of information that might just persist after death.
And what's truly amazing is how this cutting-edge physics lines up with ancient Eastern thought. The quantum idea of consciousness being a sequence of distinct moments is incredibly similar to the Buddhist concept of the self being an emergent illusion. In Taoism, the soul itself is an emergent property of different spiritual components. It's like modern science and ancient wisdom took different paths, but they might be arriving at the very same place.
And so, that's the question we're left with. We've journeyed from simple ants to genius AI all the way to the quantum workings of our own minds. And we've seen this one principle, emergence, at work everywhere. So if your self, everything you are, your memories, your personality, is just an emergent pattern, a complex and beautiful dance of information, what happens when the dance is over? Where does the pattern go?
Health is the most precious gift. If this video helped you or someone you love, please like, subscribe, and share so more families can stay safe and healthy.